All right, here is the September trial exam or the November 2020 paper 2 question on, this is the other half of electrochemistry. This is the electrolysis half of electrochemistry. It says the simplified diagram below represents an electrochemical cell used for the purification of copper. The impure copper, here's my impure copper over here, contains small amounts of silver and zinc as the only impurities. Okay, so we know that when we purify copper, what do we want to do? We want to take solid copper, turn it into an ion, and redeposit it on the other electrode as pure copper. So what happens here in this electrolytic cell, we have the electrolyte, which allows the passage of ions. And on this side, we have copper metal going to the copper cations, okay? And this releases 2 electrons, which travel through the external circuit. And then on the other side, on the other electrode, we have the copper 2 plus ions going and gaining 2 electrons and becoming copper metal, okay? So from your table of redox potentials, you have exactly the same reaction. On one side is the forward reaction, and on the other side is the backward reaction, and it's all powered by the battery. And electrons flow through the circuit, and cations and anions flow through the solution over here. Okay, so define the term electrolysis. It's the chemical process in which electrical energy is converted to chemical energy. Write down the name or the formula of 2 positive ions present in the electrolyte. So in order to have electrolysis occur and the purification of copper, we obviously have to have the copper 2 plus aqueous ions, and you don't really get copper 1 plus ions, so you can't say they don't occur really in aqueous solution. Copper 2 plus is much more stable, so you're more likely to get the copper 2 ions, which you either write as copper 2 ions or as Cu2 plus aqueous. Now, what are your other choices of what is present there? I quite like wanting to write hydronium ions because it's in aqueous solution, but that's not in the memo. So you're now left with your choice of silver and zinc that can possibly have come out of this impure copper over here. So which one is going to come out? Well, it is going to be the zinc, the Zn2 plus aqueous ions, or the zinc 2 ions. Why? If you've ever watched a displacement reaction, you will know that the moment you put zinc in a solution of copper ions, the zinc metal will immediately turn into ions and try to remove the copper ions from solution to form pure copper, because zinc is just much happier as an ion and it can easily shove its electrons onto copper 2 ions. So the zinc 2 ions will be there, the copper 2 ions will be there. If you refer to your table of standard reduction potentials and you check where the reaction is for silver to go to a silver ion, silver's like, it ain't doing nothing. It's too far in the wrong direction on the table. Now it says to you, write down the half reaction that takes place at the cathode. So you know that this whole reaction is Cu2 plus 2 electrons goes reversibly to Cu. The whole thing that's going on here is on one electrode is the forward reaction, on one electrode is the backward reaction. What is happening at the cathode? I always tell people that if we do this, we write oil rig, red cat, okay? So red cat stands for reduction occurs at the cathode, okay? So it is now asking me, write down the half reaction that takes place at the cathode. It is a reduction reaction. What does oil rig stand for? Oxidation is loss, reduction is gain of electrons. So in this equation here, what is gaining electrons? If we add electrons. So at the cathode, reduction will occur. Reduction is gain of electrons. So the copper 2 plus ions at the cathode are gaining 2 electrons and becoming copper metal. So that is the half reaction that takes place at the cathode. Then it says to you, refer to the table of standard reduction potentials and explain why the purified copper will not contain any zinc. Well, if we go look at our table of standard reduction potentials over here, and I'm looking at table, the A table, can you see here copper 2 plus 2 electrons goes to copper 0,34, and zinc 2 plus 2 electrons goes to zinc is minus 0,76. This minus tells you this reaction does not want to occur. This plus tells you this reaction will occur quite readily. So zinc ions do not want to become zinc metal. They do not want to form on the electrode. But in terms of answering the question, look at these arrows on the side here. What does this arrow say? It says increasing oxidizing ability, and this one goes increasing reducing ability. So what has got a stronger oxidizing ability? Copper 2 plus. What has got a weaker reducing ability? Zn2 plus. So to go back to answer the question, when it says refer to the table of standard electrode potentials and explain why the purified copper will not contain any zinc, we have to be very clear here. When we look at those reactions, it is Zn2 plus going to form Zn. That is the reaction we are interested in, the forward reaction, not the reverse reaction. So what do we know about zinc 2 plus when we look at the table? Zinc 2 plus, does it have an increasing oxidizing ability? No, it has a lower oxidizing ability. So Zn2 plus, not zinc, but the zinc ion, they are not the same. The Zn2 plus ion is a weaker oxidizing agent. You can also possibly write that Cu2 plus is a stronger oxidizing agent, but we're more interested in the zinc. Okay, so Zn2 plus is a weaker oxidizing agent than the copper 2 plus. Be sure that you've got the copper 2 plus ion and the zinc 2 plus ion. So zinc is a weaker oxidizing agent than copper 2 plus and will not be reduced to zinc. Okay, so basically you just have to make sure that from your table over here you check in terms of oxidizing ability. This forward reaction wants to happen. Cu2 plus goes to copper. Zn2 plus does not want to go to zinc because it is a weaker oxidizing agent, and so it is not reduced to zinc. Now it says to you, calculate the maximum mass of copper formed if 0,6 moles of electrons are transferred. So if we want to calculate the mass of copper, we know that we're going to have to use the equation. The number of moles of copper is going to be equal to the mass over the molar mass, or we can say the mass of copper, if we rearrange this formula, is equal to the number of moles times the molar mass, which we'll get from the periodic table. Okay, but what is going on here? It says 0,6 moles of electrons are transferred. So if we have a look at this balanced equation over here, we can see that 2 moles of electrons is equivalent to 1 mole of copper metal. Remember, this is an ion and this is the metal. They are not the same. Okay, this is a lovely blue solution. This is a lovely red gold metal, a red brown metal. So what goes on in any balanced equation? We can use the mole ratio. So 2 moles of electrons are equivalent to 1 mole of copper. So if we had 0,6 moles of electrons, we will only form 0,6 divided by 2, which is 0,3 moles of copper. Okay, so you have to realize we're only going to form half the amount of copper as there are electrons. So if we come back here, we will end up with the mass of copper. That does not look like copper. The mass of copper is going to be 0,3, the number of moles of copper, times copper from the periodic table, which I do believe is what, 63.5. So what is the answer to that? Work it out in your calculator. I get something like 19,05 grams of copper will be formed.